Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will take us into one of the universe's most mysterious promises, the speed of light. Why nothing can outrun it, why nothing with mass can ever quite catch it, and what would happen to time, to cause and effect, and to the very structure of reality if something ever did. But before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe, only if you truly enjoy these calm explorations through science and imagination. And when you're ready, leave a comment to let me know where in the world you're listening from and what time it is for you right now. I always find it beautiful imagining all of us scattered across this small blue planet, each of us in our own pocket of night, yet sharing the same glow of curiosity. Now, if you can dim the lights, let the room fall into a soft hush. Maybe there's the faint hum of an air conditioner or a quiet fan nearby, a sound steady enough to be a background heartbeat. Take a slow breath, let your shoulders ease. Feel how even this moment, this tiny stretch of time between two breaths, exists only because light itself travels at a very particular speed. It's the rhythm that keeps everything connected and in sequence. Tonight we'll follow that rhythm back to the moment when humanity first realized light wasn't instantaneous. We'll see how a Danish astronomer's patient eyes on Jupiter's moons led us to question the universe's timing. We'll drift with Einstein through his daydreams of chasing a beam of light, and we'll gently uncover how this one cosmic number became not a barrier, but the very fabric that holds space and time together. So, make yourself comfortable. If your mind drifts while we travel, that's perfectly fine. The light we're following tonight has been crossing the darkness for centuries. It will wait for you. Our quiet exploration now turns to the first moment that changed everything. The daylight became measurable. Long before anyone spoke of relativity or space-time, there was a question so simple it almost sounded like a riddle. When you look at a star, are you seeing it as it is or as it was? For centuries, most people assumed light moved instantly, as fast as thought itself. When you lit a candle, its glows seemed to fill the room in an instant. How could something so swift possibly have a delay? In the late 17th century, an astronomer named Rømer began watching the small moons that circled Jupiter, tiny bright dots that vanished and reappeared with clockwork precision as they slipped behind the planet's shadow. These moons, especially the one called Io, were like celestial timepieces. Rømer noticed something curious. Their eclipses didn't always arrive exactly when expected. Sometimes they were early, sometimes late, by as much as 20 minutes over the course of a year. At first, this inconsistency seemed like error, like the trembling hand of the observer. But Rømer's patience outlasted doubt. He realized the delays matched the Earth's own orbit. When our planet was moving away from Jupiter, the light from Io took a little longer to reach us. When we moved closer, the flashes arrived sooner. The difference, he deduced, meant light took time to travel across space. It was a quiet revolution. No trumpets, no thunder, just the faint ticking of an idea that the universe doesn't show itself to us in real time. Everything we see is already memory. The moon we admire is 1 1/3 seconds old. The sun shining so warmly on our skin left that light about 8 minutes ago. Even the nearest stars are years away in time. The night sky isn't just distance, it's history suspended in glow. Rømer didn't know the exact speed. His instruments were simple, his calculations approximate, but his insight cracked open something cosmic. Light, for all its brilliance, moves at a measurable pace, and that pace would become the cornerstone of everything we later understood about motion, time, and reality itself. For the first time, the human mind had touched a boundary that wasn't visible, but absolute. The thought that there might be a universal tempo, a fastest possible heartbeat, was astonishing. It meant that the universe might not be infinite chaos, but a carefully timed dance. Centuries later, others would refine his measurements. In 1728, James Bradley used the tilt of starlight to estimate its speed. In 1849, Hippolyte Fizeau sent a beam of light between the teeth of a spinning wheel and caught its reflection 8 kilometers away. He found it moved at roughly 300,000 kilometers per second, give or take a few thousand. That number would echo through every equation to come. Even so, it's strange to think we still haven't truly measured light speed the way we measure a car or a thrown ball. The physicist Derek Mueller once explained this elegantly. To measure the speed of anything, you need 2 clocks, one where it starts, one where it arrives. And those clocks must be perfectly synchronized. But the moment you try to synchronize them, you need light to send the signal, and if light itself has the delay you're trying to measure, the task becomes circular. So in the end, we only ever measure light's round trip, not its one-way journey. We can't know if it moves equally fast in every direction. We simply define it that way. Einstein himself admitted that it's a convention, not an experimentally proven fact. A beautiful choice of simplicity that makes the universe's math work seamlessly. It's comforting in a way. The idea that what we call a constant might also be a quiet agreement between us and nature. The speed of light isn't something we chase and capture. It's something we accept, like the stillness between heartbeats. As we follow the thread a little further, this realization that light has a finite speed, and that speed defines what can and cannot happen, becomes the seed of something far greater. From it, relativity will bloom, time will bend, and the straight lines of the universe will begin to curve. But for now, imagine that distant moon of Jupiter flickering behind its giant planet. Each time it disappears and returns, a silent message travels across hundreds of millions of kilometers, carrying not just light, but proof that even in the vastness of space, patience has meaning. And perhaps, as you sit here listening, you can sense a little of that patience, the gentle delay between the world as it is and the world as we see it, a delay that turns sight itself into time travel. Our story now drifts toward the young man who dreamed of chasing that light and what he found when he imagined catching it. In the late 19th century, a clerk sat in a small patent office in Bern, Switzerland, reviewing designs for electrical devices. His name was Albert Einstein, and while his days were filled with paperwork, his nights belonged to thought experiments. The hum of the city faded, and inside that quiet room, he asked himself questions that would change how humanity understood motion, time, and light itself. He imagined himself riding beside a beam of light, not in the way that a bird follows the wind, but truly keeping pace with it. What would he see? Would the light freeze beside him, a still ripple of brightness suspended in space? Would the colors vanish? The very idea made no sense. Light could never be still because being still would mean it had stopped being light. This single thought, so simple, so impossible, began to unravel the old fabric of physics. Until then, scientists believed there must be some kind of invisible medium through which light moved, like air carrying sound or water carrying waves. They called it the ether. But experiment after experiment failed to find it. Light, it seemed, didn't need anything to travel through. It simply was, a self-sustaining dance of electric and magnetic fields weaving together through emptiness. Einstein realized something remarkable. Maybe the speed of light wasn't just a feature of light, but a feature of reality itself. It wasn't that light happened to move at a fixed pace. Rather, space and time conspired to ensure that nothing could change that pace. Wherever you were, however fast you moved, if you measured light, you'd always find the same result: about 300,000 kilometers per second, or, as Einstein would later call it, simply the cosmic constant. Imagine two travelers passing each other in the dark, each carrying a flashlight. To one, the other seems to be rushing by at great speed, yet the light beams from both lamps still move away at exactly the same rate. The universe adjusts itself, slowing time here, stretching space there to keep the balance. It's like an orchestra constantly tuning itself so that every instrument, no matter where it plays, keeps perfect pitch. This idea became the foundation of what Einstein called the special theory of relativity. He proposed that time and space are not separate things, but part of a single woven fabric. When you move through space, you automatically move through time in a different way. The speed of light. In words that flow more gently, every bit of matter hides a tremendous amount of energy, locked away by light's own rhythm. That quiet relationship, mass and energy as two sides of the same coin, reshaped everything, from the birth of stars to the glow of a light bulb. When hydrogen atoms fuse in the heart of the sun, a small fraction of their mass disappears, transformed into radiant energy that will travel across space and 8 minutes later warm your face. Every sunrise is proof that Einstein's insight was true. Yet, Einstein didn't arrive at this conclusion through machines or measurements. He arrived through imagination. His gift was not just mathematics, but empathy for the laws of nature, an ability to see from their point of view. He asked how the universe might appear to a traveler moving at light speed, or to someone standing still. And he trusted that nature would never contradict itself. In his world, even time could stretch and slow, not as illusion, but as necessity. It meant that now was no longer universal. There was no single ticking clock marking the same moment for everyone everywhere. Each heartbeat, each atom's vibration, each flicker of light carried its own measure of time. The universe, it turned out, was not a single drumbeat, but a symphony of overlapping tempos, all held together by the steady rhythm of light. It was a revelation, both mathematical and profoundly human, because in its quiet way, relativity whispered something about perspective, that what you see depends on how and where you are. Two people can witness the same event and measure it differently, yet both can be right. The truth, like light itself, holds steady between them. If you could step outside of time and watch the whole universe as a single tapestry, you'd see every event past, present, and future stitched together along the threads of light. Stars exploding, planets forming, eyes opening, all linked in one continuous pattern. It's not that light rushes to keep up with us. It's that we're moving inside its unbroken rhythm. Einstein often said that imagination was more important than knowledge, because knowledge tells us what is, while imagination reveals what could be. His imagination revealed a universe where boundaries were not barriers, but harmonies, where motion and stillness, matter and energy, time and space were not opposites, but translations of each other. From the small desk in that quiet office, he had rewritten the laws of motion, not by rebellion, but by listening to what the universe had been trying to tell us all along. And so, with the speed of light no longer just a number, but the very thread that ties existence together, a new question emerged. If this speed defines reality itself, what happens as we begin to approach it? What does it mean to move closer and closer to the rhythm that holds time still? Our quiet exploration now turns to that edge, to what happens when we try to chase light, and why the closer we come,
the stranger time becomes. For a long time, the universe must have seemed like a stage with an invisible floor. You could move, measure, compare distances, and imagine that beneath it all, something solid, something absolute, held everything in place. When the notion of the speed of light arrived, it didn't just rearrange the scenery. It changed the stage itself. Most physical constants are like quiet agreements between nature's forces. But light speed is more than an agreement. It's the backbone that keeps those forces speaking the same language. The number itself, about 300,000 kilometers each second, is not chosen or tuned by anyone. It's born directly from the way the universe allows electricity and magnetism to move together, always in harmony. If you could slow your thoughts enough to picture it, imagine space as a calm ocean, invisible and still. Within that ocean, two waves, one electric, one magnetic, dance together. When the electric wave rises, it creates a magnetic one beside it, which in turn births another electric one, and together they chase each other endlessly. That mutual rhythm, their pulse, defines what we call light. And the speed of that pulse isn't optional. It's set by how strongly the universe ties electricity and magnetism together. In the language of physics, the strength of those ties is described by two values: how easily electric fields form an empty space, and how much resistance magnetic fields meet there. If you multiply those two tendencies and take the square root of their inverse, you get the speed of light. But rather than worry about equations, imagine that the vacuum itself hums with potential. Not truly empty, but full of tension, waiting to become light. The moment a spark stirs that harmony, releases as motion, racing outward at exactly one pace, the pace allowed by existence. Everywhere in the universe, no matter where you go, that pace remains the same. You could cross the Milky Way or hide between atoms, and the beat would never waver. It's not just the speed of light. It's the speed of causality, the rate at which reality can share information about itself. It's the ultimate courier of what happens next. This is why Einstein's discovery was so profound. The constancy of light speed doesn't simply govern brightness or vision. It governs time, order, and logic. If light moved faster in one direction than another, cause and effect could tangle. Events could arrive before they began. Reality would lose its sequence, and the idea of now would crumble into nonsense. The universe's coherence, the very idea that one thing leads to another, depends on light's unwavering tempo. Think of it like the heartbeat of existence. If that heartbeat ever stuttered or changed, every star, atom, and law that depends on it would lose sync. Galaxies might still swirl, but their rhythm would no longer hold. You could say the speed of light is the sound the universe makes when it breathes evenly. Even our most precise definitions now bow to that breath. Since 1983, the meter, once defined by the length of a metal bar, has been redefined as the distance light travels in one tiny fraction of a second. That means we no longer measure light speed. We measure everything else by it. Light is not a traveler moving through the cosmos. It's the measuring stick that creates space and time as it goes. There's something poetic in that inversion. The faster we try to understand the universe, the more we realize we're built from the same rules we're chasing. The tick of your watch, the pulse in your wrist, the signals between your neurons, all of them exist because light's rhythm sets their stage. You're not outside that rule. You're woven into it. Sometimes physicists speak of light speed as a limit, a boundary no mass can cross. But maybe that's the wrong tone. Limits can sound cruel, like locked doors. In truth, this one is an act of mercy, a balance point that keeps the universe from tearing itself apart. If light could go faster, energy would explode uncontrollably. If it was slower, the cosmos would collapse inward before stars could even form. Somewhere between chaos and silence, the universe found the perfect tempo for creation to endure. You can see it everywhere once you know how to look. A lightning bolt splits the sky, yet the thunder that follows is delayed because sound is slow. The light reaches you first, teaching you that even on Earth,
Speed. If you could see it drawn on a chart, the line would rise sharply at first, then begin to curve, flattening toward a ceiling that it will never quite touch. The closer you get to light speed, the heavier your ship seems to become, not because it's gaining actual weight, but because its motion through space-time demands more and more energy to maintain. Imagine trying to push a shopping cart that grows heavier every second you move it, until at some point, no amount of strength can budge it further. That's what happens when you try to chase light. Each pulse of energy adds to the ship's total momentum, but part of that energy now goes into bending time itself, stretching your moments thinner. To reach light speed would require infinite energy, a cost so high the universe simply refuses to let you pay it. We often think of infinity as something vast and generous, but here it becomes a quiet wall, not a cruel one, but one that keeps everything stable. It's what prevents the cosmos from exploding into chaos. The laws of relativity aren't punishments. They're the geometry that keeps all stories coherent. Even if by some miracle you could harness unimaginable energy, you'd face another problem. The universe is not empty. Between stars float tiny atoms, fragments of dust, invisible threads of radiation. At ordinary speeds, these particles are harmless, but when you move at a significant fraction of light's velocity, every one of them becomes a bullet. A grain of sand striking your ship could release as much energy as an explosive. A single atom of hydrogen would smash into your hull with the violence of a cosmic ray. If you could see ahead, the darkness in front of you would start to glow faintly, blue. Not from external light, but from the countless collisions of dust and gas with your protective shield. As you accelerate further, that faint glow would brighten into a blinding blaze, a storm of radiation, forming what physicists call the photon wall. You'd be racing toward a horizon of a light so dense that every particle in your path is transformed into pure energy on impact. To shield against that would require materials no known science can provide. Even the most durable metal would melt instantly. The heat would rival the first moments of the Big Bang. Temperatures beyond 10 to the 32nd power in Kelvin, or roughly 1 followed by 32 zeros. A heat so incomprehensible it turns language itself to vapor. And yet, as impossible as it sounds, there's another layer of strangeness. From your perspective inside the ship, time begins to slow. Each second on your clock lingers, like a heartbeat that hesitates between pulses. Time itself begins to stretch. Einstein's theory of relativity tells us that this isn't an illusion. It's not fatigue or machinery slowing down or perception warping. It's a fundamental truth about motion. As you move faster through space, you move slower through time. The total motion through both must always add up to the same constant, the pace of light itself. The universe gives you a choice. You can spend your motion crossing space, or you can spend it passing through time, but you cannot spend more than what the universe allows. Picture it like a traveler walking across a wide field. If the traveler walks straight east, every step takes them fully in that direction. But if they start walking northeast, part of their motion now goes north. They cover less ground eastward because some of their effort bends into another direction. Time and space behave like that, intertwined directions in one grand landscape. The faster you go through one, the less you move through the other. For the passengers inside your ship, nothing feels unusual. Your coffee still steams, your pulse still beats its steady rhythm. But far away on Earth, your friends watch their clocks spin faster. Days pass for them,
while for you only hours drift by. The higher your speed, the greater the divide. It's called time dilation, but in simpler words, it's the slowing of your own personal story. We see this not just in imagination, but in experiments every day. High-energy particles called muons rain down from cosmic rays, striking our atmosphere. These particles should decay almost instantly, vanishing in millionths of a second. Yet, because they're moving near light speed, their internal clocks tick more slowly. To them, time stretches enough for them to survive the long haul to Earth's surface. Even at the smallest scales, the cosmos keeps its promises. We also rely on this effect whenever we use a navigation app or check the time on our phone. The satellites orbiting high above Earth tick at a slightly different rate than clocks on the ground, because they move faster and feel less gravity. Engineers must correct for this every day so that our positioning systems don't drift. Without Einstein's strange adjustment, your GPS would be off by kilometers within minutes. Even our morning commutes are subtly woven into the curvature of space-time. Now imagine again your ship racing through the dark. At 99% of the speed of light, time on board runs 7 times slower than it does for observers back home. That means if your mission lasted 1 year for you, 7 years would have passed on Earth. At 99.9%, the difference grows to 70 times slower. And if you could somehow reach 99.999% of the speed of light, time inside your ship would crawl tens of thousands of times more slowly than it does outside. From your perspective, you might spend just a handful of years on the journey, but by the time you return, entire civilizations could have risen and fallen. The world you knew would be a fossil of memory. You would have outrun change itself. Not because you moved faster, but because your passage through time became gentler, thinner, stretched like silk. There's another side to this same story. As you approach light speed, not only does time stretch, but space begins to contract. Distances in the direction you're moving shrink. What once seemed impossibly far, a star 10 light-years away, now seems closer, compressed by the bend of space-time. It's as if the universe is folding itself to make your journey possible. Though from the outside observer's point of view, nothing has changed. To those left behind, you appears to be crawling, slowed by the weight of your motion. To you, the universe itself is what's shifting. Stars sliding nearer, galaxies squeezed like reflections in a curved mirror. Two realities equally valid, both held true by the same law. Relativity doesn't destroy truth, it multiplies it, showing that reality has more than one vantage point.
Light from behind you would stretch toward red, dimming into warmth like dying embers. The world would tilt, not because of illusion, but because your motion through space-time changes how light itself reaches you. Space, color, and time all warp together in one seamless choreography. It's tempting to call this distortion, but in a deeper sense, it's a kind of harmony. The universe adjusts itself so that the speed of light remains sacred, no matter who observes it. Even as time slows and space shrinks, the overall rhythm stays constant. Every frame of reality, from your frozen heartbeat to the glowing stars, works together to keep the law unbroken. If you could stop and think, really think, at that edge of near-light motion, you might sense something profound. You'd realize that light speed isn't an arbitrary limit. It's the universe's way of protecting the continuity of experience. It ensures that everything that happens unfolds in a consistent order, cause before effect, creation before consequence. It's a safeguard against chaos. Without it, moments could overlap and contradict, and time itself would lose meaning. From a more poetic view, it's as if the universe loves stories too much to let them jumble together. It insists that one event follows another, like verses in a poem. Time dilation, space contraction, these aren't obstacles. They are the way the cosmos keeps its narrative coherent. It makes you wonder, doesn't it? If light's rhythm shapes the structure of time, then every second you experience, every breath, every heartbeat, every pause between thoughts is part of that same cosmic tempo. You're not outside it, you're it, moving gently through the grand composition. As we drift deeper into the story, one question still glimmers in the dark. What would it feel like to move at the very pace of light itself? For photons, the universe holds no waiting, no before or after, only an eternal now. What would such existence mean, where all of time collapses into one moment? Our quiet exploration now turns to that impossible perspective, the world through the eyes of light itself. If we could somehow step into the mind of a photon, that tiny pulse of light leaving a star and crossing the cold vastness of space, what would the universe look like from its perspective? It's a strange thought because a photon doesn't have eyes or a clock. It doesn't feel time the way we do. And yet, imagining that view helps us understand something profound. That light does not simply travel through the universe, it defines the universe's very sense of motion and order. To us, light takes time to cross distances. We measure its journey from the sun to Earth as about 8 minutes, or from the nearest star as over 4 years. But for light itself, there is no waiting, no countdown. From its own frame of existence, the moment it leaves a source and the moment it arrives somewhere else are one and the same. The entire voyage, billions of kilometers, perhaps billions of years, happens in what to light is a single instant. This isn't poetic exaggeration, it's what relativity tells us. Time slows down for objects as they move faster, and at the ultimate limit, the speed of light, time simply stops. Not metaphorically, but literally. For a photon, the universe doesn't unfold as a movie reel of moments. It's one continuous image, an unbroken exposure of existence. Imagine the glow of a distant supernova, a star that ended its life in a brilliant flare millions of years ago. That light has been traveling ever since, crossing voids, weaving past galaxies, and tonight perhaps it reaches your eyes. To you, the event happened unimaginably long ago, but to the photon, no time has passed at all. It was emitted and absorbed in the same cosmic breath. The entire span of millions of years collapses into a single, timeless moment of exchange. There's something hauntingly beautiful about that. Every photon of sunlight that warms your skin left the sun before you even began your day. Yet from light's own perspective, it's touching the surface of your face the instant it left the star. It never experienced the journey because the journey for light simply doesn't exist. That means light doesn't see the universe as a place full of distances. To light, all points connected by its path are one point. The road between here and there vanishes. In a way, the photon lives in a dimension where the entire cosmos is compressed into the present. It experiences no before or after, no far or near, only the eternal now. For us, that's almost impossible to imagine. We are creatures built to experience time as a flow, a gentle unfolding from one moment to the next. But light invites us to think differently. It shows us that time's flow depends on where you stand or how fast you move through the cosmic fabric. For light, there is no fabric at all, only the pattern itself. Einstein once remarked that for the photon, time is meaningless. But there's another way to read that. Perhaps for light, every moment of the universe is equally alive. Every sunrise that ever was, every star yet to be born, every heartbeat yet to happen, they're all present in the quiet awareness of light's journey. We often speak of light as a messenger carrying information from the past. When you look up at the night sky, you're not seeing stars as they are, but as they were, sometimes thousands, even millions of years ago. The faintest glimmer you see might have begun its voyage before human civilization existed. Yet that same light, which left before our species could name it, still carries its message faithfully to your eyes. It has no concept of delay or loss. It simply arrives as though it had never left. You could say that light is both the storyteller and the story itself. It writes the universe's autobiography as it travels, recording what happened, where, and when. Even though, from its own view, all those chapters are simultaneous. And when light interacts with matter,
When it's absorbed by your eye or a leaf or a solar panel, it doesn't experience it as an ending. To light, there's no end or arrival. The moment of creation and the moment of completion are stitched together. The glow of a candle and the warmth on your hand are two ends of the same thread, existing at once. This strange perspective hints at something deeper, that perhaps time as we know it is not an absolute flow, but a way our slower selves make sense of the world. We are built to move through time at a measured pace, so we can experience growth, cause, and meaning. But beneath that slow rhythm, light weaves a timeless structure, a framework on which the rest of existence unfolds. From a photon's point of view, the entire history of the universe, from the first flash of the Big Bang to the final dimming of the last star, could be seen as one eternal event. Every photon of light born in that first blaze would still be crossing space today, carrying that ancient moment within it, unchanged and undimmed. In a very real sense, when we study light, we're touching the edge of creation itself. It's humbling to realize that even now, the light reaching us from distant galaxies has been on its way for billions of years. Yet from its own timeless perspective, it's only just begun. Every photon is a note in the symphony of the universe, a piece of eternity vibrating through time's illusion. And so when we talk about the speed of light, we're really talking about the structure of reality's heartbeat. For light, speed is not a journey. It's a state of being. For us, speed is how we measure our movement through time. Between those two views, the eternal stillness of light and the flowing change of our lives, lies everything we call existence. If you ever find yourself watching sunlight through a window, take a quiet moment to think about it. That glow is ancient, yet it touches you in the same instant it left its source. It's a reminder that time is elastic, that even the smallest flicker of brightness carries the story of the universe folded within it. From here, our story bends toward what happens when something tries to break that rhythm, when a ship, a signal, or a thought dares to go faster than light. The results, as we'll soon see, don't just stretch imagination, they begin to unravel the very idea of order itself. Picture yourself once again in that quiet spacecraft, drifting in deep space where the stars shine unfiltered and eternal. You've already learned how time stretches and space folds when you begin to chase the light. But now imagine pushing harder, firing the engines again and again, each pulse trying to close the gap between you and that unreachable horizon. What happens when you try to push past the universe's patience? At first, you'd feel the familiar press of acceleration. Your instruments would show your velocity climbing, the stars ahead slowly drifting blue, their light condensed by your forward motion. But soon you would notice something puzzling. Each pulse of energy seems to give you less progress than before. Your fuel gauge drops rapidly, yet your speed barely increases. You're spending effort but gaining less and less in return. That's because you've reached the strange zone where the rules of motion shift from ordinary to cosmic. The faster you go, the more energy you need to go faster still. And the curve of that need rises like a mountain that never stops. If you doubled your speed, the energy requirement wouldn't simply
The final fraction, or the full 100%, the number of energy units required would soar toward infinity. Infinity isn't a quantity, it's a boundary where all numbers lose meaning. The universe doesn't allow such a demand to be met because it would require all the energy that has ever existed, everywhere, forever. If you could gather every ray of starlight, every burning core of every galaxy, and pour it all into your ship's engines, it still wouldn't be enough. Light speed is not a goalpost, it's a wall painted into the foundation of space-time itself. But that's not the only resistance you'd face. The faster your ship moves, the heavier its motion becomes. Not in weight you could step on a scale and read, but in the inertia that resists every further push. The ship itself seems to gain a deeper stubbornness, as though the very fabric of reality is holding it back.
The energy you give it no longer translates into motion. It sinks into the warping of time around you, thickening the flow of seconds and stretching each instant thinner. And then there's the invisible storm you would begin to encounter. Space may look empty, but it's filled with the faintest dust, lone atoms, and stray particles. At ordinary speeds, they drift like harmless pollen. At near-light velocity, they become bullets made of pure energy. A single speck of dust striking your ship's hull would release as much force as a high explosive. Even the rarest particle of hydrogen, so thinly scattered that billions float in every cubic meter, would become deadly. Each one carries the kinetic power of a tiny cosmic bomb. To shield against that would require armor thicker than any planet's crust. And the paradox is cruel. The thicker the armor, the heavier the ship, and the more impossible acceleration becomes. Even magnetic fields, the invisible shields used to protect astronauts from radiation, would buckle under the onslaught of high-energy particles. Your journey would end not with a fiery crash, but with a gentle shimmer of disintegration as your craft was torn apart molecule by molecule. And yet, the deeper mystery lies not in the destruction, but in the reason for it. Why should energy itself rebel against our desire to move faster? Why does the universe spend so much effort holding us back? The answer hides in the balance between energy and mass. The same insight Einstein revealed more than a century ago. Every bit of energy has a weight to it. Every ounce of matter has energy locked within. When you accelerate an object, you're not simply pushing it through space, you're increasing the energy that defines its very identity. The more you add, the more the universe counts it as mass, and the heavier it becomes in its motion. It's as though the universe keeps its books perfectly balanced. You can borrow motion from time or mass from energy, but you can never have both endlessly. To accelerate something all the way to the speed of light would require transforming all the energy in the cosmos into a single purpose. And even then, the moment you tried to reach that last infinite decimal step, the accounting would break. Infinity is not an open gate. It's a safeguard. In a way, it's as though the universe is protecting itself from its own collapse. If mass could reach light speed, time would stop for it, and its mass energy would become infinite, a state too dense to exist anywhere but in theory. Everything we know would crumble under that paradox. So the cosmic wall isn't cruelty, it's compassion disguised as mathematics. It's the law that keeps energy finite, motion ordered, and causality safe. And there's still another challenge. Even if your ship could somehow defy the infinite energy requirement and shield itself perfectly from radiation, you would face the strange consequences of time itself slowing to a near stop. From your seat inside, the universe ahead would seem to compress, distances folding into a tunnel of distorted light. Meanwhile, for any observer watching from afar, your ship's clocks would seem to tick slower and slower until they appeared frozen. You'd never quite reach the finish line, at least not from anyone else's point of view. To them, you would appear forever caught in the act of accelerating, asymptotically approaching light speed but never achieving it. They would see you fade toward a horizon that never arrives. And to you, time would almost stop. The outside universe flashing forward into unimaginable ages in the span of your one elongated second. This isn't science fiction, it's the very geometry of reality. Every equation that describes motion includes this quiet promise. Nothing with mass can match the rhythm of light. Not because light is privileged, but because light is the rhythm. The closer you come, the more that rhythm folds around you, turning energy into time and time into resistance. The wall is everywhere, invisible, perfectly still, yet it shapes the motion of galaxies and the beating of every human heart. If you pause to think about it, that boundary feels less like a prison and more like a horizon we were never meant to cross. A horizon that gives structure to everything we experience. The fact that we can't reach it is the reason anything can exist at all. As our journey drifts onward, we'll soon encounter what happens if we push this to its breaking point. What the universe does when something tries to pierce that boundary, and what unimaginable storms awaken at the threshold of light. Imagine your ship now approaching the ultimate threshold, the very edge of the possible. You've spent years accelerating, adding more energy than any human could ever hope to gather until your speed is so close to that of light that numbers can hardly describe it. From inside, the cabin is eerily calm. Your heartbeat sounds slow, deep, steady. The dials show time itself softening around you, every second stretching like taffy under invisible strain. But outside, space is no longer quiet. Ahead of you, a storm is building. At first, it begins as a faint shimmer, a bluish haze around the ship's nose, almost beautiful. But that glow isn't reflection or dust, it's radiation born from every particle and photon. You're plowing into space, which once looked empty, reveals its hidden crowd of atoms, wandering electrons, and tiny fragments of cosmic dust. At ordinary speeds, they drift like harmless pollen. At near-light velocity, they become bullets made of pure energy. A single speck of dust striking your ship's hull would release as much force as a high explosive. Even the rarest particle of hydrogen, so thinly scattered that billions float in every cubic meter, would become deadly. Each one carries the kinetic power of a tiny cosmic bomb. To shield against that would require armor thicker than any planet's crust. And the paradox is cruel. The thicker the armor, the heavier the ship, and the more impossible acceleration becomes. Even magnetic fields, the invisible shields used to protect astronauts from radiation, would buckle under the onslaught of high-energy particles. Your journey would end not with a fiery crash, but with a gentle shimmer of disintegration as your craft was torn apart molecule by molecule. And yet the deeper mystery lies not in the destruction, but in the reason for it. Why should energy itself rebel against our desire to move faster? Why does the universe spend so much effort holding us back? The answer hides in the balance between energy and mass. The same insight Einstein revealed more than a century ago. Every bit of energy has a weight to it. Every ounce of matter has energy locked within. When you accelerate an object, you're not simply pushing it through space, you're increasing the energy that defines its very identity. The more you add, the more the universe counts it as mass, and the heavier it becomes in its motion. It's as though the universe keeps its books perfectly balanced. You can borrow motion from time or mass from energy, but you can never have both endlessly. To accelerate something all the way to the speed of light would require transforming all the energy in the cosmos into a single purpose. And even then, the moment you tried to reach that last infinitesimal step, the accounting would break. Infinity is not an open gate. It's a safeguard. In a way, it's as though the universe is protecting itself from its own collapse. If mass could reach light speed, time would stop for it, and its mass energy would become infinite, a state too dense to exist anywhere but in theory. Everything we know would crumble under that paradox. So the cosmic wall isn't cruelty, it's compassion disguised as mathematics. It's the law that keeps energy finite, motion ordered, and causality safe. And there's still another challenge. Even if your ship could somehow defy the infinite energy requirement and shield itself perfectly from radiation, you would face the strange consequences of time itself slowing to a near stop. From your seat inside, the universe ahead would seem to compress, distances folding into a tunnel of distorted light. Meanwhile, for any observer watching from afar, your ship's clocks would seem to tick slower and slower until they appeared frozen. You'd never quite reach the finish line, at least not from anyone else's point of view.
What feels like seconds. At this boundary, Even meaning begins to blur. What does it mean to move, if time no longer moves with you? What does journey mean when all distances have collapsed into one? To chase light is, in a sense, to chase timelessness, to step beyond cause and consequence, to approach a state where reality itself hesitates. And if by some impossible twist we could break through that wall, if we could somehow exceed the speed of light, then every law that defines our existence would begin to crumble. Time, the gentle thread that holds all stories in sequence, would no longer agree on what came first. Cause could arrive after effect. Actions could echo backward. The past would lose its anchor, and the future would spill into the present like water through a broken dam. If you try to stop, one physicist once wrote, the universe itself would shudder. And it's true. The balance that keeps matter and energy coherent depends entirely on the constancy of light. If that rhythm were broken, every particle, every atom, every chain of events would unravel. The laws that let stars shine and thoughts arise would no longer hold. It's strange to realize that this fragile limit, this speed we can never reach, is also what allows everything else to exist. The catastrophe isn't a punishment for curiosity. It's the natural defense of a universe that guards its coherence. The cosmic wall isn't a border of cruelty. It's the edge of harmony. Beyond it, reality itself cannot sing. And yet, even knowing that, the question lingers like a whisper in the dark. If crossing that boundary would destroy time, what would destroy even mean in a place where time no longer flows? From here, the path of our quiet journey bends toward that paradox. If motion beyond light speed unravels the rhythm of cause and effect, what would a universe without sequence feel like? What becomes of meaning when consequences can arrive before their causes? Our exploration now turns to that eerie landscape, a place where the footprints of time overlap themselves, and where light's protection of order begins to falter. If we follow the shimmer of light just a little further, we arrive at the edge of something even stranger than destruction, a place where logic itself begins to tremble. Up to now, every law of physics has quietly protected one ancient principle: that cause must always come before effect. It's the foundation of reality storytelling, the rhythm that allows everything from falling raindrops to thoughts in your mind to make sense. But at the moment we imagine moving faster than light, that rhythm begins to falter. Causality is simple enough to picture. Every event leaves a footprint, and the next one follows in its path. A seed falls, rain comes, a plant grows. One thing happens, then another, always in order. Even when life feels unpredictable, this chain remains unbroken. It's the invisible line that connects every because to its therefore. But if something could outrun light, it could also outrun those very footprints, stepping back onto its own trail before it was ever made. Imagine tossing a stone into a pond and watching ripples spread outward. Now imagine if one ripple moved faster than the others, looping around the pond to arrive before the stone even hit the water. The surface would carry the echo of an event that hadn't yet occurred. That's what faster-than-light travel would do to time. It would let effects arrive before their causes, ripples before impact. Physicists have long recognized this strange possibility. In the equations of relativity, the line that separates before and after, the light cone, defines what parts of the universe can influence each other. Everything inside that cone is linked by light or slower signals. Everything outside it is untouchable, elsewhere, forever beyond reach. But if you could move faster than light, you'd pierce that boundary. You'd cross into regions that, by definition, shouldn't yet exist for you. To us, that might sound thrilling, like skipping ahead in a cosmic book. But to the universe, it's a nightmare of paradoxes.
If a message could travel faster than light, it could reach its destination before being sent. You could, in theory, send yourself a warning not to press a button. And if you listen to your own message, the button would never be pressed, meaning the message could never have been sent. Cause dissolves into contradiction. This is what scientists call a causality paradox, a loop where logic feeds on itself until meaning disappears. In everyday life, these paradoxes are harmless thought experiments. But in the mathematics of space-time, they represent a fatal flaw. Once cause and effect lose order, the structure of reality, that steady march from past to future, collapses into chaos. Theoretical physicists have even played with ways to visualize this. They describe something called a tachyon, a hypothetical particle that always moves faster than light. To us, it would appear to travel backward in time. A tachyon could leave one point, reach another, and arrive before it departed. It's a ghost of motion, always moving too quickly for the universe to acknowledge it properly. If such particles existed, they would destroy causality everywhere they went. But there's no evidence for them. Their very nature makes them impossible to observe because interacting with them would mean sharing their impossible rhythm. Most scientists think of them as useful ghosts, mathematical fables that warn us what would happen if the universe ever lost its sense of sequence. Stephen Hawking once offered a gentle, almost humorous reassurance. He called it chronology protection, the universe's way of defending its own timeline. It seems, he wrote, that the universe is safe for historians. In other words, nature guards its storylines. It refuses to allow events that would make its own history unreadable. Whenever a physical theory allows time travel or superluminal signals, some hidden factor, gravity, instability, or sheer improbability, quietly closes the door again. It's easy to imagine the universe like an author editing its own script, smoothing out contradictions before the story can tangle beyond repair. Each law of physics is an act of self-consistency, a promise that what happens will never unhappen. This self-editing may sound restrictive, but it's also deeply comforting. It means that everything you remember, every path you've walked, every decision that shaped you is safe within a web of unbreakable order. Even the most advanced concepts of relativity bow to this rule. When scientists try to design faster-than-light mechanisms, warp bubbles, wormholes, shortcuts through space-time, they often find that the math introduces time loops or paradoxes. A traveler could return before leaving, meaning an earlier version of themselves. In such scenarios, the equations usually break down. The energy requirements become infinite, or the structure collapses instantly. It's as if the cosmos recognizes the danger and quietly erases the possibility before it can spread. Yet human imagination doesn't give up easily. The dream of outrunning time continues to call us. There's something irresistible about wanting to peek beyond the final page, to see tomorrow before it arrives. Perhaps it's not arrogance, but curiosity. The same curiosity that once led us to measure the speed of light itself. But there's a delicate irony here. By wanting to see the future, we risk unmaking the very fabric that gives the future meaning. If events no longer have a sequence, then tomorrow becomes meaningless, a painting with all its colors smeared together. The laws that seem to limit us are in truth the ones that allow us to exist as observers at all. You can think of causality as the spine of the universe's book. Without it, all pages would collapse into one incomprehensible blur. The speed of light, constant and unyielding, is what keeps the story legible. It's the gentle hand turning each page in the right order. And so, even as we imagine faster-than-light travel, we should listen to the universe's quiet warning. Breaking light's rhythm wouldn't just bend time. It would silence the very rhythm that makes time real. Still, humanity's restlessness endures. If we can't run faster than light, perhaps we can learn to move differently, to bend the stage beneath us instead of sprinting across it.
The path ahead now turns toward that dream. The idea that maybe we could stretch space itself carrying our destination with us, instead of chasing it. Our quiet exploration now follows that thread into the world of impossible engines, folded space, and dreams that try to make the universe itself move. If we follow that thought, the wish to move without breaking the laws of light, we arrived at a moment of imagination so daring it feels like science fiction whispering into reality. It begins in the 1990s, when a Mexican physicist named Miguel Alcubierre sat down to think about a problem that had haunted dreamers for generations. If nothing can move faster than light through space, what if we moved space itself? His idea was audacious.
Only the fabric of space itself does. The idea was breathtaking. It hinted at a loophole in nature's rules, a way to reach distant stars, not by brute force, but by elegance. If space could expand faster than light, as it did during the universe's earliest moments, perhaps it could be made to contract and expand locally, just enough to create a shortcut. The traveler would never feel acceleration or deceleration, only a gentle drift as the cosmos folded like silk around them. But there was a catch, and it came with a poetic kind of irony. To make such a bubble, the equations demanded something nature does not willingly provide, a form of negative energy, or energy that bends gravity in the opposite direction. In the familiar universe, mass pulls things inward, gravity attracts. Negative energy would do the reverse, pushing space outward like anti-gravity in the purest sense. To keep a warp bubble stable, you'd need an enormous amount of this strange substance, possibly more than the mass energy of entire planets, or even stars. And yet, we have never seen such material exist. The closest hints come from the subtle behavior of the quantum vacuum, where tiny fluctuations blink in and out of existence, briefly creating pairs of particles and antiparticles that cancel each other out. Some physicists think negative energy could hide in those fleeting whispers of reality. But if so, it is delicate, unstable, and far beyond our ability to shape. Still, Alcubierre's idea captured the world's imagination. For a moment, science and storytelling met in the same room. Diagrams of warp bubbles appeared not only in physics journals, but on television sets and movie sets. Engineers began sketching designs, not because they could build them, but because it felt like hope. Hope that the universe might still have room for wonder beyond its limits. If you picture it softly, a warp bubble is like a moving cradle of calm. Inside it, time and space behave normally. You could sip tea, look out the window, and feel weightless serenity. Outside, however, the fabric of the universe twists into tension, folding space as easily as cloth. The bubble contracts the path in front of it, meaning your destination is not reached by speed, but by geometry. You're carried through the universe, not as a projectile, but as a thought, gliding without resistance. But that gentle image hides enormous consequences. The creation of such a bubble would require an energy density so extreme that it would shred itself before forming. The bubble's edges would churn with radiation, its front wall boiling with forces so intense that any stray atom would be torn apart. The front and rear boundaries of the bubble would also distort time itself, creating regions where the flow of moments might differ drastically from one side to the other. In essence, the ship would be riding inside a clock that ticks differently than the universe around it. Physicists later discovered another complication, one both fascinating and alarming. If a warp bubble ever slowed down or changed direction, the buildup of energy at its edge could unleash a catastrophic burst of radiation, not unlike the photon wall we described earlier. In some models, the release would rival the power of a supernova.
It seems the universe, even when teased with cleverness, still enforces its boundaries with fire. And yet the elegance of the idea remains. It tells us something profound about the way science dreams. Even when the math says no, the mind still sketches possibilities, guided by wonder more than certainty. Alcubierre's warp drive might never leave the page, but its spirit lives on, a symbol of how curiosity stretches the imagination without breaking it. To fold the cosmos, you must borrow from its very heartbeat. The warp drive at its core is less about travel and more about listening to the rhythm of space-time itself and wondering whether we might one day learn to hum along with it. And so the dream of the warp drive isn't really about reaching other stars. It's about realizing that movement is not the only way to explore. Sometimes the greatest journeys are made by bending perspective, by asking how we might experience the universe differently rather than faster. If we follow that trail a little farther, we'll find that this dream of bending space is not alone. There's another idea, older, more mysterious, that speaks of tunnels through space-time, shortcuts connecting distant corners of reality. They're fragile, fleeting, and perhaps impossible. But beneath the fantasy lies a kernel of genuine science, born from the same equations that gave us black holes. To understand wormholes, imagine space-time as a vast fabric stretched across invisible dimensions. Normally, we travel across this surface, moving from one point to another, following the gentle curves created by gravity. But gravity doesn't just bend space, it can fold it. And when the fabric folds enough, two regions that were once far apart might touch just for an instant. A wormhole would be that point of contact, a shortcut through the folds of existence itself. It's tempting to picture it as a tunnel, one mouth here, the other far away. But the reality, if it exists at all, would be stranger. A wormhole would not be a tube through ordinary space, but a bridge through higher dimensions. To enter it would be like stepping off a map into a hidden layer of the page, traveling unseen and then emerging somewhere else entirely. The mathematics of general relativity allows such structures to appear, at least on paper. In fact, the first theoretical wormhole was described in 1935 by Einstein himself, along with his colleague Nathan Rosen. They called it an Einstein-Rosen bridge. At the time, they were studying black holes and noticed that the equations could connect two different solutions, forming a throat between them, a corridor linking two distant points. For a moment, the universe seemed to hint that shortcuts might not only exist, but might already be hidden in its geometry. Yet just as quickly as the equations gave this gift, they took it back. Wormholes, according to those same laws, would collapse almost instantly. The gravitational pull at their throats would be so intense that anything trying to cross would trigger their collapse, sealing the passage before a single atom could emerge on the other side. It's as if nature allows these portals only in theory, but slams them shut in practice, guarding its deeper layers from intrusion. Later, physicists like Kip Thorne and Michael Morris revisited the idea, wondering if there might be a way to hold a wormhole open. Their solution was as strange as Alcubierre's warp drive. You'd need a substance with negative energy density, something that repels instead of attracts, pushing space outward like anti-gravity in the purest sense. To keep a throat of a wormhole open, you'd need an enormous amount of this exotic substance, possibly more than the mass energy of whole planets or even stars. And once again, we face the same paradox. To keep the tunnel open long enough for even a single photon to pass through, you'd need a quantity.
Same causality paradoxes we just explored. A traveler stepping through could arrive before they left, tangling the order of history in ways the universe seems unwilling to permit. So perhaps wormholes are nature's metaphors, a reminder that even the boldest dreams come with symmetry. For every shortcut imagined, there's a consequence waiting. For every path that folds time, there's a gravity that resists. The beauty lies not in escaping those balances, but in noticing how perfectly they hold. And yet, the idea continues to whisper to us. Maybe it's not about building one, but about recognizing that the universe itself is already full of hidden passageways, not of space, but of meaning. Each photon that reaches your eyes is a message from the past, a bridge between what was and what is. In that sense, we already travel through time and distance every day, carried by the light of ancient stars. As we drift deeper into the dream of travel, we begin to realize that the true challenge isn't breaking light speed, it's learning to move wisely within it. Because while wormholes and warp drives remain unreachable, we've begun to build subtler tools, sails made of light, engines powered by annihilation, ideas that push us forward without breaking the universe's delicate rhythm. Our quiet exploration now turns toward those real and imagined engines, toward the ways humanity continues to reach for the stars, not by defying the cosmos, but by working gently within its limits. If we follow the current of imagination a little further, we find ourselves drifting from theory to something closer to reality, the fragile beginnings of humankind's attempt to travel among the stars without breaking the universe's laws. The warp drives and wormholes may belong to the realm of dreams, but the quieter ideas, the ones that work with light instead of against it, already exist in the laboratories and sketches of engineers. These are not engines of defiance, they are engines of patience. One of the most beautiful among them is the photon sail. Picture a thin sheet of reflective fabric, lighter than a whisper, thinner than a hair, but stretched wide, like a silver petal. In the silence of space, even light itself can push. Each photon that bounces off the sail transfers a tiny bit of momentum. One alone would be imperceptible, but billions upon billions striking continuously can build a steady force. It's the faintest breeze imaginable, a wind made of sunlight. A photon sail doesn't roar like a rocket, it drifts. There's no smoke, no fuel to burn, no sound to mark its acceleration, yet, with time and distance, it can achieve extraordinary speeds. The longer it catches the light, the faster it goes. It's a kind of cosmic patience made tangible. A reminder that not every journey requires fire, only persistence. Projects like Breakthrough Starshot hope to use powerful Earth-based lasers to push tiny probes with sails no larger than a postage stamp toward nearby stars. These vessels would carry cameras and sensors, riding beams of light at perhaps 20% of light speed, still far below the limit, yet fast enough to reach another solar system within a human lifetime. The numbers behind it are staggering, but the vision is delicate. An armada of silver leaves gliding into the dark, propelled by nothing more than illumination itself. There's something deeply poetic about that. Light becoming both messenger and engine, a bridge between the dream of travel and the discipline of physics. Each sail would be a small echo of the universe's own rhythm, proving that obedience to its laws doesn't mean stagnation, it means harmony. But for others, patience is not enough. The human spirit, restless and daring, keeps searching for ways to pack greater energy into smaller engines. That search leads us to another idea, one that sounds more like alchemy than science: the antimatter drive. Every particle in the universe has a mirror version, its opposite. When the two meet, they annihilate each other completely, releasing pure energy. It's the most efficient reaction known to science. No smoke, no residue, no waste, just transformation. In theory, even a few grams of matter and antimatter colliding could power a ship across the solar system. But the beauty of that simplicity hides staggering difficulty. Antimatter is not something you can mine or store. It has to be created, particle by particle, in high-energy accelerators. Each atom produced costs vast amounts of energy, far more than it could ever give back. A single gram would cost more than the total wealth of our planet to manufacture. And even if we could afford it, storing it would be perilous. The smallest contact with ordinary matter, even the walls of a container, would cause instant annihilation. Scientists imagine trapping it within magnetic fields, suspending it away from surfaces like a ghost held inside a cage of invisible light. The engineering of such a system borders on the mythical. But still, we try, because imagination once stirred rarely sleeps. And perhaps that's persistence is what defines our species. Not speed, but the refusal to stop dreaming. There's another approach, gentler, but just as profound, using nuclear fusion, the same process that powers the stars. Fusion engines might mimic the hearts of suns, combining light elements into heavier ones, releasing immense energy in the process. Such ships might someday cross the vast ocean between stars at a small fraction of light speed, taking decades or even centuries to complete their voyage. They would be slow in cosmic terms, but steady, a kind of celestial migration carried by patience rather than haste. All these ideas, photon sails, antimatter drives, fusion ships, share a quiet truth. The closer we come to understanding light's limit, the more we learn to move with humility. We stop trying to break the rhythm and start learning to dance to it. The universe, it seems, rewards patience far more than force. And perhaps that's the lesson hidden inside all our striving. That progress doesn't always mean acceleration. Sometimes it means alignment. The same law that stops us from surpassing light speed also grants us the stability to build, to think, to love, and to last. Without that limit, the universe would be chaos, flickering and incoherent. The very persistence of life depends on the slowness of things. When we finally accept that, we begin to see that travel is not just about distance, but awareness. The stars are not waiting to be conquered, they're waiting to be understood. And understanding requires stillness. In the end, perhaps we'll never race beyond the speed of light, but we might learn to use it as a companion. The light from the sun will still push our sails, the annihilation of particles will still warm our engines, and above all, the light that flows through our own minds, the steady beam of curiosity, will keep guiding us forward. As one physicist once said, the universe is under no obligation to make sense to us. And yet it does, beautifully, patiently, consistently. That might be the greatest journey of all. Not crossing galaxies, but learning to listen to the cosmic heartbeat that already carries us through them. Our quiet exploration now begins to shift again, away from engines and technology, and back toward meaning itself, toward what happens if we ever truly reached light speed, and how such a moment would transform not only physics, but time, and perhaps even the universe's memory of us. Imagine a ship that has spent a lifetime accelerating. Its engines have whispered for decades, pushing gently but endlessly through the dark. Every pulse of energy has carried it closer to the cosmic edge, the boundary where the laws of motion dissolved into silence. Outside the window, the stars no longer twinkle as they once did. Their light has begun to shift, drawn toward a narrow cone ahead. Behind the ship, space glows red and distant, like the fading embers of a dying fire. Ahead, everything sharpens into a blinding point. At such speed, motion begins to feel like stillness. The view forward no longer expands, it compresses, folding the universe into a tunnel of light. Space itself seems to grow denser, every direction pulled toward the same invisible horizon. The clocks inside the ship tick slower, the rhythm stretching, seconds swelling into minutes, minutes into hours. From the traveler's point of view, everything feels normal. The pulse of the heart, the soft hum of systems, the steady vibration of the hull. But compared to the outside world, their time has thinned almost to nothing.
Their perspective stretches further and further as though eternity is unfolding inside a single breath. For the rest of the universe, eons might pass, while the traveler experiences only a heartbeat. The entire future of galaxies could bloom and wither before that single beat is complete. This is the stranger quality of light speed. It turns motion into existence and time into stillness. To reach that point would be to step outside the sequence of before and after, to arrive everywhere and nowhere at once. You would see the beginning and end of your journey collapse into a single moment of being. You wouldn't be moving through space anymore. You'd become a fixed point in space-time itself, a fragment of light frozen between cause and consequence. It's impossible to say what consciousness would feel like there. Would awareness continue when time stands still? Could a mind even register a thought if every instant lasts forever? Maybe it would be less like thought and more like presence, an eternal awareness without memory or anticipation. In that sense, reaching light speed would be less a voyage and more a transformation, a return to the kind of timeless state that photons have always known. From a distance, this moment looks peaceful, a ship balanced at the edge of creation, surrounded by a glow too bright for words. But beneath that serenity lies unimaginable strain. The energy required to hold this position is infinite, and infinity has consequences. Every atom within the ship trembles under the weight of accumulated energy. The closer you come to light speed, the more the laws of physics stretch, until the smallest particles behave as though they are infinite themselves, their mass swelling, their momentum without limit. At some point, the mathematics stops cooperating. The equations refuse to provide answers, as though the universe itself cannot imagine what lies beyond. It's not a matter of ignorance, but of principle. Light speed isn't merely a threshold of technology, it's a threshold of meaning. To exceed it would require redefining time, space, and causality all at once. You could think of it as standing before the last possible horizon. Behind you is the knowable universe, stars, matter, and memory. And ahead is the region where the very idea of before and after lose coherence. In that direction lies the impossible, a domain where time might flow backward or sideways or not at all. It's a place where the notion of sequence evaporates, where causes could follow their own effects and events might never finish happening. If such a realm could exist, we wouldn't call it space anymore. It would be something like pure geometry, a static pattern that contains all events simultaneously. The traveler who reaches it would no longer be a person moving through time. They would become part of the pattern, a still point in the web of the universe's unfolding. And yet, for all its mystery, the limit feels strangely compassionate. It prevents catastrophe, not only for the traveler, but for everything else. If anything with mass could reach this state, reality would crumble under the weight of infinite energy. Time itself would tear, and the balance that lets moments follow each other would vanish. The speed of light, then, isn't just a physical limit, it's a mercy. It's the universe protecting its own coherence, ensuring that stories can still have beginnings, middles, and ends. In that sense, infinity isn't a wall to be broken. It's the place where motion dissolves into meaning. And maybe that's why we can never reach it, because to reach it would erase the very flow of experience that allows us to wonder about it at all. If we linger on that thought, we can almost feel the gentleness in this impossible boundary. The universe doesn't forbid us from dreaming of light speed. It simply reminds us that to exist is to stay in motion, never frozen, never infinite. To be alive is to be slightly slower than perfection, always catching up, never arriving. As our story drifts further, we will see what happens if we dared to imagine stepping beyond this mercy, if we tried, even in thought, to exceed light's rhythm. Because on the other side of that threshold lies not speed, but paradox, a world where time speaks before the voice, where echoes arrive before the sound that made them, and where logic itself begins to fold. Our quiet path now bends toward those paradoxes, to the fragile edges where the end of motion becomes the end of understanding. If we drift gently past that final horizon, where the speed of light stands as a curtain between the possible and the forbidden, the air of reason itself begins to change. Everything up to now has followed a simple, comforting rule that one thing causes another, that there is always a before, a during, and an after. But when motion pushes past light's rhythm, the sequence begins to blur. Events start to trade places, and the story of time begins to eat its own tail. Imagine you're standing on a beach. The sand is smooth and the tide leaves its marks in perfect order, each wave a footprint following the one before. Now imagine the ocean suddenly running backward. The footprints begin to erase themselves before you can make them. The shore becomes a pattern of anticipation rather than memory. That is what faster-than-light motion would do to the timeline. It would make consequences appear before their causes, erasing the sequence that makes reality understandable. This reversal, though hypothetical, isn't just poetic musings. It's written quietly into the mathematics of relativity. In those equations, the speed of light acts as a boundary that separates cause from effect, a luminous thread that marks what can influence what. Inside that thread, everything behaves as expected. You can send a message and someone receives it later. But if a signal were to move faster than light, it would cross that boundary. In some frames of reference, the message would appear to arrive before it was sent. It sounds like a puzzle from a dream, but it follows directly from how space-time reshapes itself when you move near light's limit. Time and space are not fixed. They are flexible coordinates that depend on your motion. For one observer, two events might occur in sequence. For another, they might happen simultaneously, and for a traveler who moves faster than light, the order could reverse entirely. It's not a trick, it's geometry. The geometry of reality itself bending until direction loses meaning. Physicists have tried to describe this with simple thought experiments. Suppose two astronauts drift in space, several light years apart. One sends a signal faster than light, a flash of impossible information that jumps across the gap instantly. From her point of view, she's simply sending a message. But from the second astronaut's frame of reference, depending on his motion, that signal might appear to arrive before it was sent. If he could reply just as quickly, the first astronaut might receive his response before she ever pressed the button. The echo would speak before the voice. You might wonder how this is even conceivable. After all, time feels so solid to us, so absolute. But Einstein taught us that simultaneity is an illusion, that there is no universal now. What we call the present depends entirely on where we stand and how we move. Every observer slices time differently, like artists cutting the same fabric into unique shapes. As long as all communication happens below light speed, these slices never conflict. But if something were to leap across light speed, those slices would cross and the pattern would tear. It's not that faster than light travel is merely difficult, it's that it would destroy the very definition of cause and effect. If you can send messages into your own past, you can warn yourself not to send them, creating loops of logic that the universe cannot resolve. It's like trying to write a sentence where each word erases the one before it. The story collapses before it can be told. Some physicists have explored these paradoxes using imaginary particles called tachyons, hypothetical beings that always move faster than light. In theory, they could exist only in that forbidden region, forever racing ahead of every photon.
But the moment you try to make sense of them, they slip backward through time. Their equations predict negative energy, negative mass, and negative sense. They would live in a universe where cause follows effect, not the other way around. A world that cannot coexist with ours.
No one has ever truly measured how fast it moves in just one direction. To do that, we'd need two clocks, set perfectly in sync. But to synchronize them, we'd have to use light to send the signal. And if light has any delay, we'd never know it. The experiment folds back on itself, like a circle drawn without end. We define light's constancy because the universe leaves us no other way. There's something quietly poetic in that. The idea that even the laws of physics are stories we tell to keep the world consistent. We name light speed not because we can measure it completely, but because we trust it to remain the same. It's a kind of covenant between observer and cosmos, a shared promise that keeps reality from unraveling. And so faster-than-light dreams remain where they belong, on the edge of imagination, glowing softly, untouchable. They are the horizon beyond which meaning collapses, the mirror that reflects not what lies ahead, but what holds everything together behind us. As our path moves forward, it grows gentler. The tension of paradox begins to dissolve into understanding. Perhaps light's limit isn't a wall after all, but a lesson, a tempo set by the universe to keep every note in harmony. The next step of our journey leads us toward that realization, to see the speed of light not as a restriction, but as the rhythm that gives existence its shape. Our quiet exploration now turns to that deeper reflection, to the meaning of the limit itself, and what it teaches us about balance, stability, and the quiet art of simply being. For so long, humanity has looked at the speed of light as a kind of wall, the final barrier separating us from the infinite. We've called it a limit, a constraint, an impossible frontier. But maybe that word limit misses the quiet grace of what it really is. The more we understand light, the more it feels less like a locked door and more like a steady rhythm, a cosmic tempo that keeps everything in tune. If you listen closely enough, the universe hums. The hum is not sound, of course, but pattern, an invisible coordination between matter, motion, and energy. The speed of light is part of that pattern. It is the tempo that time and space use to stay in sync. It keeps the dance from falling apart. Every particle, every vibration, every event plays its own note in that vast composition. The slower movements of planets and moons follow their orbits like bass lines, deep and patient. Atoms vibrate in high notes of precision, keeping rhythm through the tick of quantum transitions. And light, that constant, unwavering measure, is the metronome. It's what allows all those rhythms to stay in time with each other. If the speed of a light were any different, even slightly, the melody of existence would collapse. If light could travel faster, forces would lose balance. Atoms would not hold. If it was slower, stars would burn too quickly, collapsing before life had time to take root. Between those extremes lies the tempo we inhabit. Not too fast, not too slow,
just enough to allow complexity, patience, and the long unfolding of stories. It's a strange thing to realize that our very ability to wonder depends on that delicate balance. The laws of physics are not arbitrary constraints, but acts of quiet generosity. They shape a world where stability can exist, where energy becomes matter, where matter endures long enough for consciousness to bloom, and where thought itself has time to reflect on the rhythm that holds it. In that way, the speed of light is not a cage, but a heartbeat. It sets the pace for everything that follows. The flicker of atoms, the flow of rivers, the aging of stars, even our perception of time, the slow march from morning to evening, is built upon the way light connects events. Without that constant, there would be no sequence, no continuity, no story. Perhaps the most beautiful part of this realization is that it brings physics and feeling closer together. Science at its core is not about domination, but alignment, finding where our understanding fits into the music already playing. The cosmic tempo is not ours to change, but to appreciate. You could think of it like music itself. Every song needs a time signature, a rhythm that keeps the melody coherent. Too fast, and the notes blur into chaos. Too slow, and the song never breathes. The universe, in its quiet precision, found its own tempo written into the speed of light. It's the measure by which galaxies spin, stars pulse, and hearts beat. And yet, like all good music, this tempo isn't rigid. It allows variation, harmony, and surprise. Within the boundary of light speed, the cosmos explores every possible motion. Particles dancing, fields vibrating, life emerging. It's not a stillness, but a playground of patterns where freedom thrives because the rules are firm enough to make sense of it. There's a soft wisdom in that. We often think freedom means breaking limits, but perhaps true freedom is moving beautifully within them. A dancer is not free because she ignores gravity, but because she understands how to move with it. The painter doesn't resent the edge of the canvas. Those edges are what make the art possible. The universe, too, paints within its boundaries, and the result is everything we know and everything we love. So maybe the speed of light isn't there to stop us. Maybe it's there to give us form. It allows reality to remain coherent, giving matter the stability to endure and energy the discipline to transform gracefully. It's a reminder that perfection isn't about infinity, it's about balance. This balance is what allows existence to tell a story instead of being an explosion of nonsense. Time unfolds one moment after another because light enforces that rhythm. The equations that describe motion, all those symbols and constants we write on chalkboards, are really just another way of expressing harmony. They're the sheet music of reality. Each constant a note in the melody of being. Even our consciousness depends on this structure. The neurons in your brain communicate through electrical signals, pulses that travel slower than light but guided by the same principles. Your thoughts, your memories, your sense of now are built upon the universe's timing. Every second you experience is shaped by the same tempo that governs the dance of stars. It's humbling to think that the same constant that defines the limits of galaxies also defines the pace of your heartbeat. The same speed that restrains rockets is what keeps chemistry stable, keeps vision possible, keeps warmth from fading too fast. Light's rhythm doesn't just rule the cosmos, it lives in you. Maybe that's what the universe has been teaching us all along, that to move, to exist, to think, is to participate in a rhythm much larger than ourselves. The goal was never to outrun it, but to understand it. The cosmic limit is not the end of adventure. It's the condition that allows adventure to mean something. So perhaps in the end, the speed of light is the universe's way of speaking softly, saying, "This is the tempo at which wonder can exist. The stars will rise and fade at this pace. Minds will awaken and dream at this pace, and love will take its time, because there is time to take." From here, our journey begins to settle. We followed light from its earliest discovery to the edges of reason, from equations to meaning,
from boundaries to balance. Now it's time to turn gently back toward the human story, to look up once more at the night sky and see not just distance, but memory. To see light not as a rule, but as the language through which the universe remembers itself. Our quiet exploration now drifts toward that final reflection, how every beam of light is a record of what was, how the stars above us are already ghosts of their own pasts, and how even in that delay, life found a way to bloom. Every night when you look up at the stars, you're not seeing the present moment. You're seeing time itself stretched across distance, the universe observing its own memory. Every photon that touches your eyes tonight began its journey long before you were born. Some left their stars when humanity was still learning to shape fire. Others began their flight before the Earth even existed, when there were no oceans, no mountains, only the silent swirling of dust and gas, dreaming of becoming worlds. Each speck of light in the sky is an echo, a message from a time so far removed that it might as well belong to another universe entirely. And yet here it is, crossing the darkness, painting the present with the color of what once was. Every photon is a courier of memory, a record written in brightness. To look into the night sky is to gaze not into space, but into the long corridor of the past. If you could stretch your arms wide enough to touch those distant suns, you'd be touching ancient moments that have long faded where they began. Some of those stars have already died, their light still traveling, unaware that the source has vanished. The sky, then, is a museum of ghosts, a gallery where each point of light is a preserved instant of cosmic history. The farther you look, the older the exhibit becomes. And yet, it's not a sad museum. It's alive. Because in those ancient rays, the universe is watching itself. Each photon bouncing off your eyes as part of an endless dialogue. The cosmos seeing, being seen, and knowing that it exists through the act of illumination. If light is the fastest messenger possible, then we live in the slow unfolding of its stories. Everything we
Can see are so far away that their light has been on the road for over 13 billion years, almost the entire age of the universe. When we observe them through telescopes, we're not witnessing what they are now, but what they once were, mere infants in a young cosmos. Light gives us the gift of sight, but also the gentle reminder that every vision is a delay. And this delay is beautiful, is what allows us to understand the universe's history. Each ray of light carries a signature, a pattern of wavelengths that tells us how old it is, how far it's traveled, and what it encountered along the way. Astronomers read these patterns like letters, learning about the birth of stars, the collision of galaxies, the expansion of space itself. This expansion adds another layer of wonder. The farther a galaxy is, the faster it moves away from us, carried not by motion through space, but by the stretching of space itself. Over vast distances, this expansion happens faster than light can keep up. That means there are galaxies whose light will never reach us, entire regions of the cosmos moving beyond our ability to ever know them. They're not racing away through space. Space itself is growing between us. It's strange to think that, in a sense, the universe is writing letters to itself that it will never receive. Light streams outward endlessly, but the distance between the sender and the receiver grows faster than the message can travel. Somewhere, right now, there are photons leaving distant stars that will never arrive anywhere. They will wander forever in expanding darkness, their story unread. And yet even that feels poetic, as though the universe is whispering to itself, content to know that the message exists even if no one will ever read it. Perhaps creation isn't about communication, but expression. The act of shining, the act of sending might be enough. In that way, we too are part of this cosmic exchange. Our telescopes don't just receive light, they return it. Every satellite, every city, every candle contributes its small flicker to the universe's chorus of illumination.
Our species, fragile and new, has become another point of brightness, another note in the harmony of observation. The universe watches itself through us. When you stand outside on a clear night, let that thought settle softly. You're surrounded not by emptiness, but by history. Every photon that lands on your skin has crossed unimaginable space, dodged planets, passed through clouds of dust, and survived billions of years just to arrive in this moment. You, sitting here now, are the final destination of ancient light. You are where the past becomes present. There's humility in that, and also grace, because it means that you are, in a small but profound way, part of how the universe remembers itself. Every glance you take, every reflection in your eyes, becomes one more act of cosmic self-awareness. And so the night sky isn't just above you, it's within you. The light from long-dead stars now mingles with the chemistry of your body, absorbed into your cells, powering your heartbeat, guiding your dreams. You're made of old starlight, thinking about starlight, returning it in the quiet glow of thought. In that sense, the universe has achieved something astonishing. Through light, it has found a way to look back at itself. Through life, it has found a way to wonder. And through you, through every curious mind that asks why, it continues its most ancient habit, to shine, to reflect, and to remember.
carrying you gently within it. To rest is to trust that rhythm, to surrender to it, knowing that it will hold steady even while you dream. Our quiet journey now turns toward its final chapter. Not a conclusion, but a soft return. We've wandered through the mechanics of motion, the boundaries of time, the meaning of speed and stillness. Now we come home to reflection, to the quiet truth waiting at the end of the race, where light is no longer something to chase, but something to rest within. At the end of every long journey, there comes a moment when movement gives way to reflection. The engines quiet, the stars stop drifting, and you're left with the faint hum of thought. The realization that all roads, no matter how far they lead, eventually bring you home. Tonight, after wandering through centuries of discovery and light years of wonder, we arrive at that moment. Not to cross a finish line, but to look gently back at the path we followed, and to understand what the journey was really about. We began with the first flicker of curiosity, Ole's quiet patience as he watched Jupiter's moons vanish and reappear. Realizing that even light takes time, that simple observation opened a doorway that would never close again. From that moment forward, we stopped believing the universe was instant. We began to see it as it truly is, patient, rhythmic, filled with memory. Then came Einstein, sitting in his small office, imagining himself chasing a beam of light. From that dream came relativity, the revelation that space and time are not two separate things, but threads woven together into one living fabric. He taught us that the faster we move through space, the slower we move through time, and that light itself is the heartbeat that keeps those threads in perfect tension. Through him, we learned that the universe isn't just vast, it's connected. We followed that insight into the realm of speed, imagining what would happen if we tried to touch the impossible. We saw how energy rises toward infinity, how even dust becomes deadly, how light itself becomes a wall of fire before us. We glimpsed the catastrophe that would unfold if we tried to break nature's rhythm, and realized that this limit, rather than cruelty, is mercy. We explored paradoxes, the strange world where effects could precede their causes, where echoes could speak before voices, where logic itself begins to tremble. And we learned that the universe protects its own coherence. It allows imagination to wander freely, but it keeps the structure of reality intact. Light speed, that constant companion, guards causality like a shepherd tending time's flock. Then, as the story softened, we dreamed of loopholes, of warp drives bending space, of wormholes folding the fabric of existence, of photon sails gliding patiently toward the stars. We imagined antimatter engines, fusions of power and light, each one a testament to the human refusal to stop dreaming. And through those dreams, we discovered that progress doesn't mean rebellion, it means partnership. To move beautifully within the laws of the universe is a greater act of freedom than to try to break them. Finally, we came to understand light not as a barrier, but as a bridge. Every ray that touches our eyes is a memory, a message from what once was. The night sky is not a ceiling, but an archive, a living museum of time. Every star we see has already changed or vanished. Yet its light still travels, still speaks, still reaches us. We are surrounded by ghosts of brilliance. And those ghosts give us comfort because they prove that light never truly leaves what it touches. And maybe that's the heart of it. Nothing outruns light, but light outruns nothing. It waits, it lingers, it records. Even the light that escapes from your own room right now will travel forever through the void, carrying a fragment of your existence, a brief warmth, a trace of thought. Somewhere unimaginably far in the future, it might brush against another world. And for a heartbeat, the universe will remember that you were here. If you think about it, the speed of light is the universe's way of keeping time honest. It sets the rhythm by which all things live and die. It holds galaxies in their courses, and it shapes the lives of atoms. It keeps hearts beating in sequence, thoughts unfolding in order, and events flowing one into another like notes in an eternal melody. The speed of light isn't the wall of creation. It's the pulse that gives creation coherence. When you slow down enough to feel that, something quiet happens. The chase ends. The tension dissolves. The universe stops being a race to be won and becomes a rhythm to be lived. You start to see that the miracle was never about moving faster. It was about moving at all. About existing in this fleeting slowness where time still has meaning and wonder still has weight. There's a phrase astronomers sometimes use when they describe the age of starlight. They call it look-back time. It's a poetic term for how far into the past we see when we gaze across space. But maybe look-back time isn't just an astronomical concept. Maybe it's something human too. We all have our own look-back times. The moments we carry like distant stars, shining with memories of who we were, what we loved, what we lost. They remind us that light doesn't vanish when its source fades. It keeps moving. Softer, dimmer perhaps, but still traveling, still reaching. And so the speed of light becomes more than a number. It becomes a lesson in patience. It teaches us that everything we send out, words, kindness, laughter, even grief, travels onward. Maybe not instantly, maybe not always visibly, but inevitably. Every act of care, every shared spark of thought is a form of light. And light, as we know, does not die. It only moves forward. As this quiet journey draws to a close, take a moment to feel how strange and beautiful it is to exist in a universe that knows how to remember itself. A universe that keeps its memories in beams of light and its meaning in the stillness between them. The fact that we can look up, measure, imagine, and dream within those beams means that we too are part of that memory, both the observer and the observed. So if you ever find yourself staring into the night sky, feeling small beneath the weight of infinity, remember this: you are not outside the story. You are the way the story learns to see itself. You're a tiny portion of the universe made conscious, reflecting the same light that began everything. The limit that keeps you grounded is the same one that allows you to shine. And as you sit there now, perhaps with the eyes heavy and thoughts beginning to drift, the light that began its journey billions of years ago is still reaching you. It hums quietly through your window. It softens against your skin. And it reminds you that time, no matter how vast,
always carries its warmth forward. So rest now, traveler. The stars will keep their watch. The universe will keep its rhythm. And light, that faithful constant, will continue to weave every moment into the great tapestry of being. Thank you for joining this quiet exploration. Whether your eyes are still open or already dreaming, may you feel at peace inside the tempo of the cosmos. If you'd like to return again for another journey, another story told softly under the light of distant suns, you're always welcome here. Until then, sleep well and let the light carry you.